that this is a rational function. I want to remind you that rational means that you can write it as a fraction. The whole unit's called rational functions, and that's all you've been doing so far is giant fraction problems. Sometimes the denominators in the beginning were just like nice numbers, but eventually it's fractions that have variables in them like this. So do you get that's like the simplest of all fraction functions? 1 over x. All right. It's a fraction function. And do you remember what it looks like? Do you remember it looks like that? All right. Now I'm going to talk to you a little bit about the asymptote and what a hole in a graph is and what domain means. So let's just do it one at a time. It says, why did an asymptote occur at x equals 0? See, there's an asymptote right on that line. That's the line x equals 0. The up and down line, that's a vertical asymptote at 0. Well, it's because when you stick 0 into the function, it doesn't like it. Do you get you can't have a 0 right there? Okay, I want to remind you there's two kinds of dividing by 0. One is this way, and one is this way. This way doesn't exist. Okay? So I like to say it this way. I have 8 cookies and I divide by nobody. It just doesn't make sense. If I have 0 cookies and I divide by 5 people, it's easy. We all get 0 cookies. Okay? But if I had 8 cookies and I divided by 0 people, it just like, what? It doesn't make any sense. Okay, so watch out today because sometimes you'll be tempted to figure out like what makes the top 0. What makes the top of a fraction 0 doesn't really matter. It can be 0 on the top. It just can't be 0 on the bottom. Okay? All right, so back to this. Do you get, I just said it can't be 0 on the bottom, so you can't feed it a 0. If you feed it a 0, you're going to poison the function. All right, I'm going to take that as an example of human beings. Do you get that some people are allergic to things like peanuts, for example? And I might be able to feed most of you a peanut and you'd be fine. But there's be some of you functions that would be allergic to a peanut and it would hurt you. Okay, so this function right here, the 1 over x function, it can be fed anything. In other words, all real numbers work from negative infinity all the way to infinity, but there's something along the way that wouldn't work. As you're going from negative infinity to infinity, do you get eventually you'd hit 0 and it wouldn't work, so you'd put a parenthesis like that? Everybody please write that in. What we're doing is writing the domain of this function. We're saying it works from negative infinity to infinity, but along the way, you hit 0 and it doesn't work. And then it starts working again right after 0 all the way to infinity. And what am I supposed to have between them? A u, very good. Okay. That's how you write the domain of this function. Everything works except 0. I can safely feed this function anything, any x value except 0. Now I want to show you another way you can write it because they do this on the key. Big R stands for all real numbers. All real numbers, comma, x cannot be 0. Whether you write it the blue way or the black way, either one of those is a way you can write it. But it's really common for kids to only write this. If you only write that, I have to mark it wrong. Because you don't really understand domain then. Domain is what you can feed the function. And if all you tell me is this, you're telling me what you can't feed it. What you can feed it is everything except not 0. Okay. Let's move on to slide 2. I just showed you how to do this. Let's do it with the parentheses. From negative infinity. My computer's really weird today. I'll pause for a second. Did you say that it could just go from negative infinity to infinity? No, because there was one thing along the way that you couldn't be, which was 4. And so by putting a parenthesis around the 4, you're saying it can't be 4. But doesn't it work with things that are bigger than 4? Yeah, so you write 4 to infinity, and then squeeze in a little u in between them. Raise your hand if you had that one right. Okay, I feel like you're getting it. How about this one? Oh, it's really common for people to be like, well, it can't be 2, and it can't be -1. It can be -1. We're fine with the top being 0. But what else can't it be? 0. Good. See, if I put a 0 right there, the whole function dies. So it can't be 0, and it can't be 2. That makes sense to you? So there's one way to write it where you go all reals except cannot be 0, cannot be 2. That's a way. Or -infinity until infinity with some stops along the way. Can't be 0. Starts working again right after 0 until it hits 2. And then can't be 2. But honestly, this way is kind of a pain. That's a lot easier. But on the test, if they ask you for interval notation, you'd have to be able to write it that way. So you got to kind of know both ways. All right, how about this one? If I stick in a 0, does it cause my function to die? No, because I have 1 over -12. That's legal. That's a number. 0 does not cause my function to die. So how do I figure out what makes the bottom 0? Factor it, because if you can factor it, you should. So you get it factored, and you'll figure out what would poison your function. You got an x, you got an x, you got a minus, you got a plus, because if this number is negative, it must be a plus and a minus. And then you'd be thinking 4 and 3, and I want the answer to be positive at the end, so make the bigger number positive. There we go. I factored it. Now do you see the two things that it can't be? Here's a classic wrong answer. X cannot be 3. X cannot be -4. And the kid got so close. But they did not give me a list of what it can be. So, yes. Double bar R. That is actually a math symbol, and it means all real numbers. All real numbers except 3 and -4. Yes?
Do you have to write the x doesn't equal, or can you put like a...
You have to write it exactly this way. I know it's a pain, but when we grade them, you have to say all real numbers except x cannot be this and x cannot be that. Exactly this way. There is another way, and it's if you write out all of those parentheses and do it this way. From -infinity until -4, and then it stops working. And then it starts working again at -4 until you get to 3, and then it stops working again. And then it starts working again after 3 to infinity. There, that's the other way. One of those two ways. Math notation's kind of a big deal. It's a little bit like in English, do you get that you're supposed to end a sentence with punctuation? And that's kind of a big deal if you don't. Like, yeah, it's going to be marked wrong. You can't just leave a no punctuation at the end of a sentence. All right. So I want to make sure you get this. Everybody, don't write this. Just look up and do you agree 3 and -5 are both kind of a big deal about this in this function? All right. If I do this, though, that brings extra emphasis to the 3, because do you get there's one of those x minus 3's on the bottom and on the top? Okay. This, please write this down now. This function would have a whole and it would have an asymptote. Let me make sure you understand the difference. The thing that cancels out, that's going to make a whole. And that's the thing for today. Tomorrow is about the asymptotes. But for right now, do you get that 3 is a problem? Because if I put in 3, it'll kill my function. But if it's the kind like this, where there's one on the top and the bottom, that creates a hole. Write this underneath your example. It creates a hole at 3 comma something. You put in 3, function dies. But where exactly would the hole be? The hole would be, well, how about this? Would you agree that normally in math we cancel these, don't we? So then the hole is located at 3 comma 1/8. See if you figure out where I got that. See, it says y equals, doesn't it? Y equals is telling you what to put here. See, it says y equals 1 over, if you put the 3 there, the same 3 that would have killed your function, then you'll see that the hole would have been at 1/8. 3 comma 1/8. All right. And I'd like you to write this. Vertical, just V, ASYM, that stands for asymptote. You've seen them before, the dotted lines that run up and down. At x equals -5. So, to sum up today's lesson, the whole thing, like I'm almost done, if you can understand all of this. This is a function that is a fraction function, because it's a fraction, so we call them rational function. This rational function it can be fed pretty much any number except 3 and -5. Do you get that? Okay, the two things that poison this function, the 3 is a hole, and the -5 makes an asymptote. So if we were to actually graph this, there would be a hole here and a vertical asymptote here. Now you already know what a vertical asymptote looks like. A vertical asymptote at x equals -5 means wherever -5 is, like let's say here, there's a dotted line that goes like that. Do you get that? Okay, what the heck does a hole look like? Well, a hole just looks like a point except empty. So I go to 3 comma 1/8. It's like over 1, 2, 3, and up 1/8, which is only up a tiny bit. And I put an empty spot right there. That's a hole in the function. Well, what does the rest of the function look like? I don't know. You'll be graphing them by the end of this unit. You'll be graphing them, and I can actually tell you, all you'd have to do is take your original function, which was y equals 1x minus 3 over x minus 3x plus 5. And you'd have to make a whole bunch of points. Do you know how to make points? Put in any number you want. Put in 1, see what you get. Put in 2, see what you get. Put in 3. Ooh, wait a minute. 3 was a bad one. Because as soon as you put in 3, you realize you get 0 over 0. So at 3, you get an empty spot. You have a hole there. Put in 4, see what you get. Put in 5, see what you get. And is 5 okay? Yeah, actually putting in 5 is fine. What's the other number you can't put in? -5. So let's just do one more point, just to see if you get the point. I'd like to put in the number 4. Don't even do it on your paper because I think it's just going to make it messy. But do you get that on the top I'll have 1 times parentheses 1. So I get 1 on the top. I just put in the number 4 because I'm making an XY chart. So I 4 comma what? I'm putting in a 4. I'm going to see what I get. And then 4 minus 3 is 1. And then 4 plus 5 is 9. And then 1 times 9 is 9. So I get 1/9. 4 comma 1/9. When I put in 4, I got 1/9. There'd be a dot, like right there. And you make enough dots, and eventually you'll figure out what the function looks like. which might be like this. And you're like, oh, I guess it's a line that goes like that. You don't know until you make a whole bunch of points, but do you get if I had a point here and I had a point here and I had a point here and a point there, you'd figure it out? Okay. So what does a hole look like? It's an empty spot in the graph. What does an asymptote look like? They're dotted lines like this black dotted line that goes forever. And you're not supposed to touch it. Okay, that's a lot. I said that was pretty much everything. We're on slide 2. So that from here on, it's honestly mostly just review. So let's look at this one. Do you remember the top ones are just kind of distractors? I don't care if the top becomes 0. So don't worry about 2. But what about -4? Is -4 going to cause a problem? It's going to create a what? A hole. Everybody put a hole is at what comma what? Well, what's the first part of the hole? -4. And then how do I get the other part of the hole? Hint, this would cancel, wouldn't it? Then y, that's y, equals, and I know the x is -4. -4 minus 2 makes -6. Who had -6 before I said it? Cool. See, I canceled off the thing that makes the hole. I knew -4 was a problem, so I knew that that was my x of my hole. And then I just stuck -4 into the resulting function. Okay, how about this? Domain? What does domain really mean? It means what you can safely feed the function. Like, for most of you humans, domain is just human food. If you just eat human food, you're fine. Some of you have a more limited domain. You can eat all human food, but not dairy. Or but not gluten. Or but not peanuts. All right, so what's the domain for this thing? All reals is how I'd always start, unless I'm going to write it with the parentheses and the infinities and stuff. All reals except x can't be, what can't you feed this function? -4. So that's how you could write that domain. Alternately, you could say it works from -infinity until infinity, but along the way, you'd hit -4 that it can't be. And then it starts working again after -4 all the way to infinity with a little union sign. 2 alternate ways to write your domain. I don't care. Unless on the test it says, must use interval notation. Then you'd have to use the way I wrote in black. All right. Don't worry, today you're not graphing them. But if your life depended on graphing this, all I'd do is make an XY chart and I'd find a whole bunch of points. And it's not that hard. There'd be a hole, though, at -4, -6, which, by the way, is like just off the graph down here. And there might be a whole bunch of other points that are like this. And then you'd be like, oh, there's my graph. Goes right up to the hole, but doesn't go there. Now, I don't know for sure what this one looks like. I think I could actually do it. Because after I canceled this off, has anybody ever graphed y equals x minus 2 before? It's not that crazy. What's the slope? 1, what's the y-intercept? -2, you see how I was really close, actually? Goes through there and has a slope of 1. And it doesn't hit at 0, and then it keeps going after it. I was just totally guessing, and I just barely missed it. Why is there an empty spot there? Because at -4, when you stick it in, right in here, it would have killed the function. Because it had a +4 there, and it would make 0 on the bottom. Okay, next page. Today's mostly just about the domain and the holes. So the domain, always just start with all reals, and then x cannot be, and then what can't x be? 3. Because, look, there's a hole. It's the kind that cancels, so there's a hole there. Add 3 comma something. Talon, would you shut that door, please? Some lunchtime people in the hallways where they're not supposed to be. Because it distracts people like us. Where's the rest of the whole? And I get that this is a weird one, but let's look at what's left. Y equals 3. Y equals 3. That's the line y equals 3. It's a straight line at 3. But wait, there's a hole, isn't there? Yes, there is. There's a hole at 3 comma what? 3. How do I know the y is 3? Because y is always 3. Look, it says y equals 3. Y is always 3. So 3 comma 3 must be where the hole is. So you're saying right there, Mr. Server, it doesn't actually have a point? Yep. I'm making an empty spot. There we go. Empty spot at 3 comma 3. Okay, moving on to this page. You might think you don't even care about the top, Mr. Server, so I'm not even going to factor the top. But then the problem would be you might not notice. I bet you there's an x plus 2 buried in that thing. Because do you get if there's an x plus 2 on the bottom and x plus 2 on the top, then it'll cancel and make a hole? And since the lesson is about holes today, it probably happens. Okay, so then I'll just factor this real quick. X and x. There's a minus in the problem, so there must be a minus. This number is negative, so it must be a plus and a minus. There must be a 2 in it. And there we go. Look at that. There's an x plus 2 in it. Ka-doink, ka-doink. There's a hole at negative 2 comma something. I hope you're smart enough to figure out that the y is equal to that. So if you were going to put negative 2 in someplace, it would be here. Negative 2 minus 1 is negative 3. Who had negative 3 before I said it? Nice, that's where the hole is. Negative 2, negative 3. It's down here, empty spot. But where's the rest of the line? Find points. Make an XY chart, find a whole bunch of points. But in this case, it's actually pretty easy. It's y equals x minus 1. That's the part that didn't cancel. Can you graph y equals x minus 1? It's actually weird. It's like, it's so easy, it's hard. How do you graph y equals x minus 1? Do you know the y-intercept? Do you know the slope? So then it goes through here and it has a slope of 1. There we go. And it keeps going on the other side too, by the way. So that's what a hole looks like. It's just an empty spot in the graph. Everything else is going along just fine. There's an empty spot. That's totally different than an asymptote. An asymptote would have been a dotted line like this, and it would have acted different on the other sides of the line. All right. What's the domain of this one? All reals except x cannot be what? Negative 2, because that'll make a hole, which is at negative 2, negative 3. How'd you get the negative 3? Because I stuck the negative 2 into the function. And it told me y equaled negative 2 minus 1, which is negative 3. All right, next page. I hope these are getting easier. Domain, all reals except x cannot be what? I guess x can just be all reals. On a parabola, you can go forever from left to right, and it just works all the time, so it's all reals. How about the holes? Is there any holes in this one? No. How about on this one? What's the domain of this one? All reals except x cannot be 0. Holes? Yeah, there's a hole. No, wait. There would have had to have been an x on the top, too, to make a hole. That's not a hole. What is it, then? For extra bonus points. Tomorrow's lesson. It's an asymptote. Good. Okay. There isn't a hole here. How come? Because there's no x on the top to cancel the x on the bottom. If there was an x up there, then there would have been a hole. All right, on to this one. It's so easy. You're just going to factor the top. You're going to factor the bottom. So let's start with that. Everybody factor the top and factor the bottom. You just had a whole big test that had tons of really hard factoring in it. This should be like, oh, easy peasy. Then go back and look for what makes the denominator 0. And the domain is all reals except x cannot be, etc. Good. And then how about the top? X comes out first, you're right. And then you'd have x squared plus 3x minus 4. And can you factor that again? I'm ready. X minus 1 and x plus 4. Okay. Bringing the other x up there. There it is. That's factored all the way. Now you can start going, okay, I got one of these up there and one of these down there, and that makes a whole at 1 comma something. 1 comma something. Figure out what the rest of the whole is. Hint. There is. This and this is also going to make a whole at -4 comma something. And to see what's left, you really need to rewrite this. F of x is like y equals x. It's the only thing left after this and this cancel. Y equals x. Ooh, that's the line that looks like that. That's what y equals x looks like. And then it's got a hole at, well, -4, when I stick it in, makes y equals -4. -4, -4. And 1 comma 1 are where holes are. So then I go back and put a hole here at 1, 1. And I put a hole at -4, -4. Empty spot. That's what that graph looks like. If you understood where I got the holes from, you know, which is taking the number and sticking it back in this equation of y equals x. If you didn't understand how to graph the rest of it, the graph was just y equals x. Maybe you don't remember that y equals x is just the line that runs like this. That's the line y equals x. It just has a couple holes in it. Okay. All right. That's it. Now you got homework. Homework's a little too intense. It's actually a lot too intense. A bajillion problems. So open it up. Let me show you which ones we're going to do. All right, we're just going to do the odd ones. Do the odd ones. So obviously cross off 2, 4, 6, 8, 10, etc. We're doing number 1. Abe, would you read me number 1? It's got 2 sets of parentheses. What's in them?
X plus 3.
And?
X plus 1.
How about the bottom?
All the parentheses, X minus 2. Parentheses, X plus 5.
Was there any that cancel and make a hole? Then there's no holes. Okay. What else they ask? Besides holes, what else they want to know? Ah. Which makes this function die? X cannot equal. What are the things it can't equal? Otherwise it's going to die. 2, and what else can't it equal? That's all you have to do is find the things that would make it die. Okay, number 3. Alex, would you read it, please?
x plus 1 over x parentheses x minus 3.
You see anything that cancels and makes a whole? One person was saying yes and one person was saying no. Do you guys think there's anything that cancels? I don't think so. You might think those x's cancel. They don't, because that's an x plus 1 on top. All right, so then nothing cancels. So then there's no holes. So what are the things that make this function die? X equals 3 is an obvious one. What's the weirder one? -1 is incorrect, because I don't care if the top becomes 0. What else makes the bottom 0? 0. Those are the two things it can't be. So x cannot be 3 and x cannot be 0. Get used to the not equal sign. You use it a lot this unit. All right, we're doing odds. 1, 3. Next one, logical one, is 5. Just keep going from there. If you get stuck, please ask me for help. And I'll teach you more about asymptotes tomorrow.